this session of the Technology and Innovation stream, which focuses on minerals processing and tailings management. My name's Mark Player and I work for the Australian subsidiary of German centrifuge manufacturer Flottweg SE. Flottweg's been designing and manufacturing centrifuge machines since about the 1950s, and it's recognised as a specialist in the industry with about 12,000 machines installed worldwide. So these machines were invented in the late 1900s and they've been used in a wide variety of industries, from food and beverage, chemical, industrial, water and wastewater, to name it just a few. And there's literally hundreds of specific applications that they're used in. So today I'll discuss the use of these machines within mining and minerals processing sectors. So I'll begin with a brief overview of what the machines are, how they work, and then we'll take a look at some different case stories of mining applications, including, we'll start with neutralised acid sludge in heap leach operations. We'll look at wash water sludge and the recovery of processed water, crud removal from solvent extraction plants, then tailings dewatering, water recovery from tailing streams, and a few other novel applications such as classifying and an alternative for CCD thickness. So decanter centrifuges are made they come in different sizes for differing throughputs, of course, and they range from a small machine weighing maybe a tonne and processing, say, 1 cubic metre an hour of slurry, right up to 20 plus tonnes of mass and handling 100, 200 cubic metres an hour of slurry. Now, in all cases, usually the physical size of the centrifuge machine is going to be a fraction of that for an alternative separation technology such as filter press, vacuum belt filter, conventional thickener, and this has usually been one of the reasons that they've been installed where space has been limited, or the weights, accessibility, that kind of thing. So installations in mining and minerals processing could involve just a single machine, or in cases where the throughput capacity is large, multiple machines in parallel. These machines, they're relatively low maintenance piece of equipment with a minor service activity that would take typically just one shift to complete. That'd be conducted in a 6 to 12 month interval. A more major overhaul, typically a week of day shift to complete, this is carried out on either an annual or biannual basis. The capital cost of this equipment is typically less than of the other technologies, and having a small footprint does lend itself more easily to justify having a standby machine to allow increased availability or additional capacity. So let's take a closer look at how it actually works, what's involved. So there's 2 electric motors, and one is driving a bowl via belts and pulleys, and then there's a planetary gearbox which drives a scroll or auger kind of assembly inside. Here's the rotating bowl. It'll be under a cover. It's all fully enclosed. So let's take a look inside. So here's an animation of the rotating bowl assembly. We can see a cylindrical section and then a conical section. So this is spinning around at anywhere from about 500 to 5,000 RPM, and this will produce same sort of numbers, around 500 to 5,000 G of force. So the way it works, the feed slurry enters the rotating bowl through a stationary pipe. Here it spills out and it's in a centrifugal field, and the heavier density solids will pretty much separate out instantaneously. So what will happen as they settle, this scroll or screw will it's also spinning around at bowl speed plus a little bit. We call that the differential speed. But it's continually moving and scraping the solids out till it gets to the end and is ejected through ports in the machine. Meanwhile, the clarified liquid flows in the opposite direction, and it also spills out under gravity in a continuous process. It's just operating and the speed of the scroll, it's adjusted in real time by a PLC, and it works very nicely without any operator intervention. This gold mine with a heap leaching process generates acidic waters that are neutralised with milk of lime to reach a pH around 8 to 8.5. And this hydroxide sludge that's generated has a solids concentration of only about 6% dry solids by weight, and it's coming out at a rate of 10 cubic metres an hour, which was then transferred to static sedimentation ponds in tanker trucks. And over time, problems arose because the drying in these ponds was just too slow due to the hygroscopic nature of the hydroxides in the pulp. And so the high cost of truck transport coupled with a new environmental regulation meant that a different approach was necessary. Now, a Flottweg Decanter Centrifuge dewaters this 6% solid slurry, concentrating it up to 25% dry solids. And this reduced the annual cost of transportation from $840,000 to just $42,000 per annum. The payback period for the machine was about 4 months. And separate to the transport cost benefit, the installation allowed the mine to stay in continuous operation without any environmental problems. So interesting to note, of course, acid mine water is a common problem, differs from site to site, and we've got another client whose solids are coming out at 70 to 75% dry solids, a lot higher than this case here. In that situation, it's because there's a lot of gypsum present, which dewaters more readily. So washwater sludge applications typically include sand, gravel, limestone washing, where a stream of undersize and clay ultrafines are produced and need to be removed from the commodity. And this slurry would typically be stored in dams or ponds on the site, but eventually real estate may become a problem, or the availability or cost of fresh make-up water becomes scarce. And at this point, mechanical dewatering becomes necessary, really, to reduce the solids volume or recover the water. And Decanter Centrifuge, it offers a good solution. It's a common application. So the equipment in the washing process uses a relatively clean, recycled water, and the undersized and ultrafine solids, which typically include a lot of clay, they accumulate, and they'll be concentrated in a clarifier where the underflow is fed to the centrifuge. And in this case, the sludge concentration would vary from about 35 to 45% dry solids. And so the feed pump flow would ramp up and down to maintain a constant solids load of 20 dry tonnes per hour fed to the machine. Here we can see the feed sludge and the separated streams. So the centrate really quite clear, turbidity around 45 NTU, and the solids dewatered to around 60% dry solids was quite acceptable. In this case, the goal was water recovery, and this 60% was quite handleable. It could have been achieved drier with additional flocculant, but it wasn't necessary. So to minimise the chemical cost, that's pretty much where they run it. So a single machine performs this duty without any sort of day-to-day operator intervention. And the civil structures for the plant are relatively simple, and overall this solution enabled the site to reduce their water consumption by about 35%. So solvent extraction and the electrowinning process is best known for its use by the copper industry, where it accounts for some 20% of worldwide production. But the technology is also applied to other metals like cobalt, nickel, zinc and uranium. Now, crud is a persistent problem in these facilities, and what is it? Well, it's a stabilised emulsion with ultrafine solid contaminants that accumulates at the interface between the aqueous and the organic liquids in the settlers and cause big problems for the process. So it's essential to remove the crud from the process, but historically the standard recovery techniques use filter presses, and this was very laborious and pretty ineffective because even after the filtration the crud still contained significant quantities of the organic solution and resulted in big losses amounting to hundreds of thousands to millions of dollars per annum to replace these reagents. And second to that, I mean, the residual solids had to be treated as a very hazardous waste, extremely toxic for the environment. So crud will separate under centrifugal force, and in theory there would be three phases: your organic hydrocarbon or light liquid phase, the aqueous water or heavy liquid phase, and the solids. But it must be noted that most cruds around the world will actually separate into four phases, and this is illustrated here in the spin tube, where there's a stable emulsion forming between the organic and aqueous phase. Now, the Flottweg tricanner has a unique feature called a variable impeller, and this allows an instantaneous fine adjustment to the liquid phase discharge while the machine is running. And so the operator can ensure that this fourth phase is always discharged with the aqueous phase, and this gets sent to tailings. So we can see this coming out here, and most importantly, the light liquid phase or organic solvent is recovered crystal clear and able to be sent back to the settlers and reused. The solids comes out separately. So from crud input, we recover the organic phase, the solids are removed, and big money is saved. Now, there are close to 100 Flottweg tricanners installed in solvent extraction plants globally, and the reliability of the machine is also a major advantage. Most of them are installed in very remote regions, and there are tricanners which were installed all over Africa 16 to 20 years ago, still operating without any problem. And this is an application where the payback time for the machine would be typically less than 6 months. And whilst copper crud still remains the main application for them, it's also been successfully deployed in uranium and zinc SX processes. So mechanical dewatering of tailings, it's usually employed where a conventional wet tailings storage facility is not feasible for reasons such as no available space, water scarcity such that the water must be recovered and recycled, environmental legislation more and more we're seeing, or in the case perhaps backfill required for underground workings. So a tailings dewatering solution can differ greatly depending on the site specifics, and a smaller surface or underground operation might need just one machine. The nature of the centrifuge lends itself to mobility such that equipment can be installed in short time, potentially with minimal civil and structural works. Alternatively, for larger throughputs, multiple machines are installed, and the small footprint here is favourable to minimise foundation size and the size and space for structures and cranes, etc. Water of high quality with low residual suspended solids can be recovered, and flocculants are used if there's a lot of ultrafine size particles to be removed, but it's not always necessary in all cases. The solids dryness which can be achieved will depend mainly on the particle sizes present, as well as the presence of any clays or other chemicals that can make it more difficult to dewater. But typically, the finer the particle size distribution, the more moisture that will remain in the dewatered solids. The range would vary from around 60% up to 80% dry solids, or 20 to 40% residual moisture. Here is an example of tailings in a kimberlite or diamond mine where the dewatered solids produced have from 70 to 80% dry solids content. Now the anionic polymer consumption is in the range of 50 to 200 grams per tonne of dry solids, and the power consumption from 35 to 65 kilowatts. No backwash water is used and no dedicated operator is necessary for the facility's operation. So there are some other less common but rather interesting applications where decanter centrifuges have been used because other more conventional equipment was not suitable or had some particular issues. Centrifuges have replaced conventional thickeners in CCD circuits, giving very flexible adjustment capability and once again a small footprint for the installation. Decanter centrifuge is also able to be used as an efficient classifying machine, and it is able to run clear cuts with high solids concentrations and fine particles, so things which cannot be achieved with hydrocyclones. This has been used in kaolin processing and pigments manufacturing, and we think this versatility could likely become of interest for other hydrometallurgical processes, including reprocessing of old tailings. In order to assess different separation equipment to find out which might best suit a particular operation, it's important to consider many aspects for each, and this chart summarises one such comparison for a particular mine site. In this chart, each aspect for a filter press, a thickener and a centrifuge is ranked from 0 to 5 and plotted with a score of 5 on the perimeter ranking most favourably. So first up, the definition test. This is to quantify what each machine can actually do. Now for a centrifuge, this starts with 1 or 2 litres of slurry in a lab test, and this gives a pretty good indication of what is possible with a real machine. It can be followed up by a small pilot-sized machine deployed on site, but also we could demonstrate with a real full-size machine, and this has the advantage of 0 scaling errors, plus it allows the client to get a real feel for the machine because it is the real thing. Around here we can see what we've discussed before about some of the size and weight benefits of the centrifuge, making it attractive when compared to the filter press or thickener, which are larger civil kind of structures. Further around, the ability to fit instrumentation to automate is assessed, and the personnel requirement, flocculant, compressed air and power consumption is compared around here in this section. Separation performance and the flexibility of use is compared here. We have here the adjustable range of solid content discharged in the solids. So centrifuge very flexible and able to adjust this. Not usually able to get quite as dry as a filter press, but the filter press and thickener is not so adjustable, so sometimes that can be a real benefit. Up here, the CapEx and OpEx investments required, and of course certain things will carry a higher importance for a particular operation, but in any case this type of assessment is a good starting point from where weightings can then be added to assist in final decision making. So thanks for listening. These are just some of the insights into the decanter centrifuge and its uses in the industry. If you have any questions or would like more information, please visit our virtual exhibition booth for a talk or leave your business card so we can get back to you. Thank you.